So this is Unit 1, Chapter 1.4. So it's for using limits to find slope of tangent lines. So let's just real quick, what does tangent mean? 1 point, right. It goes through 1 point on your graph. That's a tangent line. Okay? And this right here is used, okay, to figure out the slope of a tangent line through a given point. You're going to have to be given a point to figure out from where. Okay? So, like, for example, this was the given point. Okay? And what they're doing is we're going to use limits because if I looked at this line, that line slope, then I looked at this line slope, and then I looked at this line slope, and I kept looking at that line, that slope, and how it's alternating, it's going to approach the actual slope from that point. So we're going to use a limit because it's going to keep getting closer to that point, just like with our concept of limits, how it'll approach a certain number. Okay? Yeah. Okay, so this is just P and Q is like P and Q stands for the slope of the line. Okay, M is slope, right? It's PQ is point to like where to be going through the parabola. Triangle, what did I tell you guys triangle meant, remember? Change in Y over change in X. Okay, f of X is just your function. F of A is plugging in your limit, like what you're approaching in terms of the X coordinate of the point is the best way. We're going to get to it. This is kind of the visual picture in the formula, and then we're going to kind of get into actually doing it. Okay? Here's another thing right here. So this is kind of your change in X and your change in A. So like this is your point. Here's the change, like from that, like right here. For this example of this slope would be f of X minus f of A. This is the change in Y, the change in X. So X minus A, f of X minus f of A. Remember, f of X and f of A are just y's, right? They're the actual function. They're the outputs, okay, the heights, okay, your X minus A. Now, this is very theoretical. This is all letters. I understand it's kind of tough to see, so before you freak out, let's wait until we actually try one.
So having that A and the X is kind of like having X1 and X2?
Yes. Right, except for now what's going to be tricky with calculus is you're only going to be given an A, so you're going to be working with X's. Like you're going to have a variable still. Okay, that's the tricky part, but we'll get to that. Okay, anything else? Okay, so another way of writing it. Okay, so here's example 1. We're going to find the slope in the equation of the tangent line to the curve of y equals 2x squared plus 4x minus 1 at the point 2, 15. Okay, so 2x squared plus 4x minus 1, we should all be happy with. That's a parabola. That's definitely a parabola. We know it's curved. Okay, we know what that's going to look like. Okay, and we're going to follow for this one. Save this one. Okay, or these are the same, I guess. Okay, so we are going to go for this problem, limit as x goes to a of f of x minus f of a all over x minus a. So based on what we were just talking about, where are we going to get our a from? That a girl. The point, right? It's the point. And it's x approaching, so what point do we want? Do we want the x or the y? The x, right? Yeah. So it's not really rocket science on that part. We're going to 2. So we're going to do, this is what we're doing. Limit as x approaches 2 for, we still have f of x, and then we have f of 2. Okay? All over x minus 2. Now this is where we got to kind of use our brain, kind of remember everything, tie in our pre-calc. Okay? So, do we know what f of x is? Yes. It's right here. Technically, I probably should put this in the problem. That's what this is. This is f of x. So I'm going to put that in for it. So limit x goes to 2. I'm going to insert this. 2x squared plus 4x minus 1. Okay, that's the f of x. I'm going to minus what is f of 2? How can I find f of 2? You plug 2 in for x. Good. So I'm going to plug 2 in for x. If I plug 2 in for x, and guys, I'm going to do a lot of this stuff mentally, okay? So if you don't see it, let me know, or I make a mistake, let me know. 2 squared is 4. 4 times 2 is 8. Plus 8 minus 1. 8 plus 8 is 16. Minus 1 is 15. So that's right, or the point. Yeah, you're right. Okay, yes. Okay, or you could have stole from the point. You guys are smarter than me. Good job. Okay, all over x minus a, which is just x minus 2. Okay, and at this point, we're going to combine like terms, and we're going to see if we can factor, because right now, why can't we take the limit of this right now? Because what? Right, if I put in 2, I get that 0 in the bottom problem. Exactly. So we want to see if we can get an x minus 2 somehow to cancel. Okay? So here we go. So we're going to go limit x approaches 2, 2x squared plus 4x minus 16 all over x minus 2. What would you want to try next? Yeah, let's factor the top. We'll take a 2 out first. We can GCF. Okay, I'm not going to write the limit stuff right now. We're just going to do the work first. That gives me x squared plus 2x minus 8. Okay, over x minus 2. Can I factor x squared plus 2x minus 8? X plus 4, x minus 2. Good. So now we have this. Limit as x goes to 2 of 2 times x plus 4, x minus 2. All over x minus 2. And we're happy about that because it cancels the x minus 2. So, limit as x goes to 2 of 2 times x plus 4 can be done now. And what would that be? 12. Now what this is, it's important to understand what you're doing. We are taking the limit, but what are we taking the limit to find? The slope. 12 is the slope of that line. That's what this is. We have the slope and point. Exactly. Now we're going back to our pre-calc review. That's what I mean. You're not going to be tested on it, but you got to use it. So your m is 12. Your slope is 12. The question said find the equation of the tangent line. So we got to figure out the rest. Okay? Right. You put in y equals mx plus b. Okay, let me add a page here real quick. So we know m equals 12, and we know a point is 215. Okay, so like we practiced from before, we're going to plug that into y equals mx plus b. So that's going to be 15 equals 12 times 2, plus b. 15 equals 24 plus b. b equals negative 9. So we are done. The equation of that line that's tangent to that parabola at that point is 12x minus 9. So that line hits the parabola exactly at one point, 215. That's what we've just figured out. Okay? Any questions there? Okay, before we go further, let's do a quick review. Okay, quick review of, remember, vertex form. Okay, remember I talked about this a little bit last week, I believe, didn't I? Didn't we complete the square last week, briefly? I think we did. Okay, so if I have y equals 2x squared plus 4x minus 1, okay, let's complete the square here. Okay, let's practice. So what do we do first? We move something out. Move the constant out. Okay, so we're going to do. We're going to go 2x squared plus 4x plus box minus 1. Okay, now we can't complete the square if we have a what? When we want to complete the square, we don't want a 2 there. So how do I get rid of that 2? What's that? It's okay. Well, I just didn't hear you. Yeah, we want to just pull it out. They both have a 2 in common. We're going to GCF there. So we're going to have a 2 sitting outside. We're going to have x squared plus 2x plus box now minus 1. That 2 does play a part, so don't forget about it. Okay, so now we're ready to complete the square. So what's the process? We do what? Half the middle. 1. 1 squared is 1. Right? Okay. And since I added a 1 here, I have to subtract 1 here, but I have to do something first. What was that step from Math 20 we had to do? This 2 is a problem. So where I kind of explained it, maybe I didn't explain it good my first semester, but when you put a 1 here, in order, like right now it's surrounded by brackets. To get out of the brackets, it's got to hit if there's something that's outside. So what's 1 times 2? 2. So that's plus 2, so I have to minus 2. Opposite. So we didn't add a 1, we added a 2. So I have to subtract a 2 to even out my equation. So I'm just going to put a minus 2 here. Okay? So this shrinks down to 2x plus 1 squared minus 3. That is your completed square.
How did you get the 1 in the box? How did you decide that?
This guy?
Yeah.
Half the middle
Yeah.
and square it. That's the pattern for completing the square. So I have 2 and I got 1. I squared 1. I put it in the box. We always do that. It was a simple number, so it looked weird, but that's what you do there. So with that being said, just so you know, what we just did is we just found the vertex of, that was a previous problem. So what's the vertex? What's that? -1, -3. That's your vertex. Vertex. Okay, so real quick, sorry, I know I'm kind of all over the place, but real quick, the reason I did that is because now, they're not using the calculator part, we know the vertex of my parabola is -1, -3. It's right there. Is my parabola going up or down? It's going up, right? It was a positive. Okay, what was the constant on the end of it? Constant was -1, wasn't it? So that means it's going through -1. Okay, so it's going to be, so this is roughly what your parabola is going to look like. Okay, that line we just did, so 215, okay, I know it's kind of tedious, but I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 215. Mine's not quite to scale, but anyway, it'll be here, and that's going to go, what was that equation line we got? 12x minus 9. So that would come down -9. Oh, it's actually over here. Sorry. Yeah, my bad. It's not over here. On a better graph, it'd be like right about here, and it'd be something like this. That'd be our tangent line going through our parabola, roughly, is what it looked like. You can get a much better picture on your calculator than what I just did, but if you had to sketch it, you could as well. All right, so that was example 1. So with that, okay, this is another way of doing it. Okay, if you don't know, like if you don't have an x. So we're still doing change in x, but excuse me, this is another way of doing it. And you're going to see why we're going to do this long term. It's kind of the long way of doing a limit, but we're going to do it for the sake of understanding the process. So instead of x, we use a plus h. Okay, and then we use a, and then instead of x minus a, we use h. Okay, we'll get to that. Okay, but to help you out, a is a point, and then a plus h is that point plus the change. So h is essentially the change. Okay, same thing here. F of a plus h, and then f of a. Just has the change in it. Okay, think about h as the change. Okay, and it's really just another expression, but we're going to use this expression for the next example. Whenever you guys are ready here. Okay, good, Austin. Okay, so we're going to find the tangent line to the hyperbola xy equals 1 at the point -2, -1/2. Hyperbola is just, guys, it's just a thing that has an asymptote that's bending. Okay, and the reason this one's a hyperbola is because of y. Well, we always want everything in terms of what? In terms of y, right? So I want to get rid of that x there. So y equals 1 over x. That's hyperbola because I can't have 0 on the bottom. X on the bottom, I can't have 0 down there. So I'm going to have some limitations. So we're going to take the limit, okay, of that. So we're going to go, now the difference is that now we're going to be taking the limit of h as it approaches 0. So we're going to go, the best way to put it is, limit as h approaches 0, and I'm using the second expression I explained to you, of f of -2 plus h minus f of -2 all over h. Yes. Why is it h approach 0? Because this is a different type of, the best way is because last time we did x, right, and we didn't know x, so we're essentially just subbing in h for x. So h is our change now instead of our x. Because last time we did x approaches 0, right? And this time, or x approaches a. I'm trying to think the best way to explain it. So I'll get back to you on that, why it's h goes 0, but this is just a different expression, I guess the best way to put it. Right now, the best way I can tell you, it's just a different expression where we're taking it in terms of h goes to 0 rather than x goes to a. Okay? So, but with that, we still plug in -2 here, right? Because it's still going in for our x. Because it's still f of -2, so I'm plugging in -2 for my variable. So you're going to have the first part, whoops, limit h goes to 0. So f of -2 is 1 over -2. So we'll write minus a minus right now. That's the right side. The left side, this piece, would be what? What would this piece represent? What's that? Close. It'd be 1 over -2 plus h. I put this right there. Right? I put -2 plus h just in for the x. Just put it in right there. Okay, all over h, which we leave as h. So now, this is where we kind of got to use our fraction skills, is what your quiz is on. What do I want to do with these? Common denominator. Yeah, I want to get a common denominator. So I want to times, these are the same. I can't just do a plus h. It's not that easy, never is. Okay, I'm going to times this one by -2. I'm going to times this one by -2 plus h. So we times them by each other. Just leave the over h part down there at the bottom for right now. So that's going to give me, I'm just not going to write the limits for right now. That's going to give me -2 over, do I distribute? Yep. 4 minus 2h minus -2 plus h all over 4 minus 2h. Okay, so now we have a common denominator, 4 minus 2h. Don't worry about the over h. It's all over h. We'll get to that in a second. We're just trying to get these fractions together. Okay, that's what this crazy work's about right now. What's a negative 2 minus a negative 2? So what's minus a minus? Plus, so what happens? They're gone. Exactly, it's 0. Okay, so that means my top is just going to be a negative h because it's minus a positive h. Okay, that's all over 4 minus 2h all over h. Now, why is that helpful? Why are we happy now? Do you guys see it? What's that? Not quite, but you're on the right track. Where is this h going to go? Is it going to go to the top or the bottom? The bottom. It's going to go right here. So the h's are going to cancel. Okay, does that make sense? Because remember with fractions, if you were dividing these, you would flip and multiply. Okay? So the h will go to the bottom. So let me write this so it's not quite as bad. Negative h is you're going to put the h on bottom times 4 minus 2h. Those are going to cancel. So now what we have is we have limit as h goes to 0 of negative 1 over 4 minus 2h. Now this is helpful because we don't have h in the bottom anymore. 0 is not an issue anymore. That's why we had to do all of this. Okay, we can take this limit now. What is this limit? What does it equal? Negative 1 over 4. Negative 1/4. Okay, so let's think about this. What does that mean? That's the slope. Okay, on this one, it said just find the tangent. Oh, no, it says find the tangent line, so we need to find the slope. Yeah, we got to keep going here. Okay, all right, so let's finish this out. So we got our slope is negative 1/4. So next thing we're going to do is we're going to do our y equals mx plus b, figure out the rest. So our y, that's going to be, yeah, thanks. So negative 1/2 equals negative 1/4 times 2, right? Negative 2, good, plus b. Okay, what's a negative 2 times negative 1/4? Positive 2/4, which is positive 1/2. We minus a half, b equals negative 1. Okay, so our equation of our line, y equals negative 1/4 x minus 1. Let me show you what this is about now. Show you the picture. See if I can draw a better one than last time here. Okay, first thing I'm going to do is, let's go in blue. Y equals 1 over x is going to be in blue. Okay, let's just test some points. That's kind of the easiest way. If I have a 1, what's the point at? 1. 1 over 1. Okay, if I do 2, 1/2. Okay, if I do a 1/2, it'd be like 2, right? 1 over 1/2 would be 2. So we see that this hyperbola here is going to go like this. Right? Right. It's going to be approaching 0 in the infinite direction. Okay, now if I try negative 1, I'm going to get negative 1. And it's going to have the same relationship. Negative 1/2 will be negative 2. This will be a little bit flatter. So it's going to go like this. Okay. Now, our line we just figured out, it starts at minus 1. Let me do this one in green. Okay, it starts at minus 1. And it goes down 1 over 4 or up 1 over 4. And you're going to see that thing hits that hyperbola right there at one point, at a tangent. Okay? So that's what we just figured out. So I'm trying to connect it now. Makes sense. Okay, it is hitting through one point. The change formula just to show the other one. There's two different ones. This one is better when you have like 1 over x has a definite zero on the bottom problem. So sometimes the h one's a little bit better. I don't really know what to tell you in terms of what the difference is and when to use what yet, but we'll just kind of play with it and figure out. Yeah, I think the a plus h one is the one that always works. So that's the safest one, but we'll get to that. Okay. Oh, I did a picture here. All right. So that was example 3. Okay. So now we're going to look at find the tangent lines of the curve of y equals root x minus 2 at the point 6, 2. Graph the curve and the tangent line. Oh, there's only 3. I thought there was 4 examples. It's the last example, so that's good. Okay. So how about this? I'm going to let you guys try this. Okay, so for mine, I'm going to use the h approaches 0. So we're going to have limit h approaches 0, and then we're going to have f of 6 plus h, because 6 is my x, minus f of 6 all over h. Okay, so we plug 6 plus h in just for the x, and then we plug in 6 for the x. So that's going to give me limit h approaches 0. That's going to give me square root of 6 plus h minus 2 square rooted. Whoops, I did 2 square roots, I don't know why. Okay, that's the top. And we have the other piece of it, minus square root 6 minus 2, which is 4, all over h. So this is going to give us, we just keep simplifying, 6 minus 2 is 4, so it's going to be 4 plus h minus 2, all over h. Is everybody with me still? So this is where, in your head, should be ringing conjugate. What can I do with the conjugate? So I'm going to do the conjugate, because like right now, you're like, I can't get the h to cancel, so I'm kind of stuck. I still have h at the bottom, so I can't do the limit as h approaches 0. So we've got to use our pre-calc stuff. 4 plus h plus 2 to top and bottom. So that gives you 4 plus h minus 4 all over h times 4 plus h plus 2. The reason I leave the h out is because I can see on the top 4 minus 4 is 0. I can cancel my h's. So these go away. That cancels. So now I'm left with 1 over 4 plus h plus 2. The 2 is not underneath there. And now we can plug the 0 in. Okay, when I plug the 0 in now, 4 plus 0 is 0. Square root of 4 is 2. I get 1 over 2 plus 2. So my limit is 1/4. My limit is 1/4 again. Okay, and let's finish this out here. So we got to get the equation. So y equals mx plus b. M is 1/4. What was our points again? 6 and 2. So 2 equals 1/4 times 6 plus b. That gives you 6/4. So 2 equals 3/2, because 6/4 is 3/2. Minus 3/2 minus 3/2. 2 minus 1/2 is 1/2. Okay, so we have y equals 1/4 x plus 1/2. So let's look at this picture here. So like I showed on the board there, the x minus 2 graph starts at 2 and goes like so. Over 1, up 1, over 2, it's going to be, it's going to be 1, 2, 3, 4. That'll be 2. That's pretty good there. That's what the graph will look like, the original. Okay, and our graph that we made, you'll see, starts at 1/2. It goes up 1 over 4. So essentially that's going to be the 0.26, or whatever we had there. But anyway, that would be the tangent spot that goes through to 2,6. Mine's a little bit off, or 6,2, sorry. Oh, so it actually can hit right here. Let's actually draw it good then. So it's actually going to draw, it's going to go through this point here. Little curve. But anyway, we get the idea. And that's it for today.